Far East. Europe. Paris, Amsterdam, London, BBC, 369. 369.
Plans for the official opening are being discussed by a joint Anglo-French committee which began meeting in Paris today. The chairman... and he hopes that simultaneous ceremonies will be held in London and Paris. Negotiators at the Geneva trade talks have agreed to meet again next month to discuss the latest proposals submitted by...
What I want to know is why haven't they been checked? Well, maybe I didn't mention it, but you're an engineer. You can think for yourself. You know those loops are important. Hold on a minute, Wilhelm.
Morning, Stan. Sorry to bother you so early again, but I had a thought last night. Something went wrong with my television set.
Yeah, hold on a minute, Mary. I'm on the phone. Make yourself at home. Hello, Wilhelm?
Sorry about that. Now, that's top priority for this morning, degasification loops. I'll be there in half an hour, and let's get some urgency into this.
I'm the only one around here who seems to realize we're running out of time.
Can I help?
Do you know anything about degasification loops? Sorry. Do you want some coffee?
No, thanks.
Sorry about the mess. I'll tidy up when all this is over. Now, what's your problem?
My problem?
Yeah. Well, you said something about your television set.
Oh, that. Look, I don't want to waste your time.
No.
Is there somebody who can tell me about telecommunications?
Sure. What do you want to know?
Oh, it's nothing, just a thought. I want to ask him a few questions, but I don't want to bother you.
There's Dr. Walter. He could help you. Walter.
So good of you to see me at such short notice, Dr. Walter.
You're most welcome, but you do realize that I have a party of English students here.
Yes, so I was told.
They are visiting under the European Educational Scheme for Technological Experience.
In your field, Dr. Walter, I'm a student myself.
Then you will not object to joining them.
I'd be glad to.
Good. Please take a seat for a second, Purchace.
Thank you.
Good morning.
Good morning, sir.
Today, I want to talk to you about geosynchronous communication satellites.
Dr. Walter, what does geosynchronous mean?
Can one of you explain? Quiet, one at a time. You.
It means that the satellite and Earth are travelling around at the same time, so the satellite always seems to stay in the same place.
But it's got to be over the equator, and the distance from the Earth is 36,000 kilometers.
Very good. The first satellite of that kind was Early Bird, launched in 1965. Now, there are many series of them. What are some of their names? Intercept. Someone mentioned Intercept. There are new series. You know what they are used for?
Communication with other satellites.
Correct. They provide the link between satellites in low orbit and ground control centers all over the world. Now, let's take an example of a low-orbiting satellite.
Eureka?
Carsat?
Carsat. Very well. Let us suppose this is Carsat orbiting at over 25,000 kilometers per hour. Now, it has to move so that one of its antennae is always pointing to the Intercept series further out in space. And the Intersat has to keep its antennae pointing at the orbit of Carsat in the same way. Now, what happens to the signal when it reaches Intersat?
It's amplified and then sent back to Earth.
Then it's amplified again.
Now, why is it amplified so many times?
Because a lot of the signal strength is lost on the way.
Right. And do you know how many times a signal has to be amplified after it has traveled 36,000 kilometers?
1,000 times?
I should think it's more like 1,000,000 times.
The figure is 100 million times. That's why we send the signals in very narrow beams to concentrate them as much as possible. The area that the beam covers at the receiving end is known as its footprint. The footprint may be comparatively small, so the direction has to be extremely accurate.
What happens if the beam moves off target?
Communication will be lost until the antenna is readjusted.
How often does that happen?
The availability of communication satellites, the period in which they remain in the window, is almost 100%.
Almost.
The actual figure is 99.98%.
That does leave 0.02% when communication is broken.
How very perceptive.
Morning, Bill.
Good morning.
I thought Stan would be here.
I'll be back in a moment.
Everything all right? What's this?
These, they are the degasification loops. Two rotary pumps pump liquids through the electrode chambers to remove the gas formed by the electric current. The gases are extracted from these chambers here. If one of these loops were to fail, then gas would build up and it...
Hi, Mary. How'd it go?
Oh. Well, I don't know if it's important, but Dr. Walter says that sometimes there are breakdowns in communication between satellites and ground control.
Sure there are.
Well, suppose there was a breakdown in communication between Carsat and Earth at the precise moment that something went wrong with the production unit. That could have caused a gap in the log. And the data, which would have explained why the pump dropped to half speed, would be missing.
Mary, one of the first things they did at ESOC was to check out the telecommunication link to make sure there'd been no break. There was no gap in the log. They also checked with the Earth station where the signal was received. They confirmed there was no break at that time, okay? All right. Wilhelm, how far have you got?
I was
Well,
just
very
starting
well. There wasn't any break. But suppose there was some interference with the signal. Interference from space, for instance. So that the signal wasn't actually interrupted, but it was, well, affected in some way.
You mean corrupted it?
Corrupted, that's the word I mean. So that the computer got the wrong information. Well, that wouldn't have been logged, would it?
That's very unlikely.
Unlikely, but the more we look into this, the more I'm inclined to believe that there was some kind of corruption in the log.
Then why wasn't there corruption in the other data from Carsat as well as our own?
You know more about satellite tracking than I do.
Mm-hmm. And you know more about degasification loops. Can we get on with it?
Stan, you mentioned the Earth station. Which one was it?
Carsat was in contact with Intersat 4, so Reisting was the Earth station.
Not far from here.
Or shouldn't we go there?
Mary, I don't have the time. I want to check these loops and about 100 other things.
Mary does have a point. Someone should go.
All right. I'll go. Mr. Gelberg.
How do you do?
How do you do? An amazing building.
It's a radome, which shields an antenna from the wind. I'm afraid it's very old-fashioned.
Old-fashioned?
It's our oldest antenna. We don't use this method of protection anymore. Let me show you inside. It's really something. We have to go through the airlock. You see, the entire structure is partly supported by increased air pressure inside it. And there is the antenna. It's a big one, 32 meters. It can tilt to any angle, and it can turn in 2 complete circles.
You mean it moves?
Sure thing. It's moving all the time to keep track of a satellite in deep space. Since the satellite is very far away, the movement is very slow. You see, the whole structure is raised off the floor to allow it to turn. There are 2 motors under there, and they work in opposition to each other, so there's no backlash in the gears. Would you like to go up?
What I really want to...
It will only take a few minutes. No, we could use the elevator, but you see so much more if you walk. We are now at the axis of the dish. This antenna has one great advantage from the point of view of the visitor. You can actually see how it works. You can even feel it moving.
Feel it?
Yes. If you put your hand just here, you can feel the gear wheel turning.
So you can?
Yeah.
Mr. Galberg, is
Yeah?
this the antennae that you use to track into Sat 4?
Oh, no. We use one of our modern ones for that, please. It's very beautiful, don't you think? Mm-hmm. Of course, the shape is determined by the need to reduce wind resistance. But I like to believe that when the engineers designed it, they wanted it to be beautiful.
Is this dish receiving signals from Intersat 4?
Sure thing, 24 hours a day.
And from lower-level satellites that communicate with it, such as Carsat?
That's right.
Where are they amplified?
The dish itself amplifies the signal 2 million times. That's what we call the antenna gain. Then there's a preamplifier inside the structure.
And after that?
The signals are processed at our main building. I'll show you our equipment over there.
Mr. Galberg,
Yeah?
is it possible that signals from space could interfere with, corrupt, the signals from the satellite?
Yes, it is possible. If a low-orbit satellite and a communication satellite are in direct line with the sun, we get a lot of background noise from the sun.
Do you keep an exact record of when that happens?
Oh, we do better than that. We always know when it's going to happen. We warn our users in advance.
Oh.
So any failure in the degasification loops is extremely unlikely. Okay. Hi.
Hello?
Well?
A fruitless journey, I'm afraid. The signals from Carsat weren't interrupted. You were quite right.
You're a real trier, Mary. I'll grant you that.
Did learn something, though. Some engineers have souls.